Okay, 2.3 notes. We're going to talk about functions and identifying functions and what makes a function. And hopefully, as we talk about some of this, it's going to help with questions you've had from the last couple days. And just know on Monday when I get back, we will go over all this and see what kind of questions you have and make sure we're all caught up on the same page. So, when you think about functions, you should have a couple things you're already thinking of because you've talked about functions before. In junior high, you talked about like function boxes or function machines. Remember when you had like a function and you had the in out and there was something inside the box like 3x, and so everything you put in, you figured out what came out of the box. Those are functions. And you've done tables, T-charts or tables where you've done the X and the Y, and there's been something that happened in between where you figured out what the input and output were, I guess, or what you've probably seen before. So thinking about that, go ahead and make your prediction for the V and the E. Which one do you think is a function, the V or the E? I'll give you a hint. They're both not functions. Only one of them is. Okay, so they're both relations because a relation is just a set of ordered pairs. And I'm going to write this down before I lose my track. Okay, so both the letter V and E above are points, and you could, if you wanted to, plot the points on the letter, and those would be the ordered pairs that would make a relation. Same thing with the E. You could find places to put points, and you could write the ordered pairs, so it also would be a relation. But only one of them is a function. And the difference is V is actually the function and not E. The way you tell if it's a function is here's the cheater way you think of a function is it has no repeating x's. And that works for us. But when you get to algebra 2, you're going to have to think about it a little bit more specifically than that. What a function is think about the 3x we put in before. For any number you put in for x, there's only one y. Or one y value, let's put that. Okay. Any number you put in for x, there's only going to be one y value that matches it. So if you think about that for this letter E, if you put in for x 0, you would get this point right here, you would get this point right here, and you would get this point right here. So there are actually 3 values of y for the x. So that makes it not a function. What I just did here with my pencil is called the vertical line test. So the vertical line test tells you to make a vertical line, which I probably don't need to write, but I'll write it anyway. If the relation crosses the vertical line more than once, it is not a function. So you ask yourself, crosses relation more than once? More than one time? No function. So when we're looking at a vertical line, and you should be able to put a vertical line anywhere, and you should only cross your relation, which is the line that's connecting the V and the E. If you cross it more than once, anywhere, it's not a function. It doesn't matter if there's one place where you only cross it once. It doesn't matter. If there's any vertical line anywhere in the relation, then where it crosses the vertical line more than once, then it is not a function. Okay, so here's this really weird thing that happened. I was looking at this worksheet as I was working it out ahead of time, and after I just said no repeating x's, I looked at number 1 and I saw repeating x. So guess what? Number 1, not a function. I don't know quite how that got messed up, but number 1 is not a function. Number 2 is a function. So make sure you cross that out. It's kind of a weird thing. Okay, so let's talk about the different ways we can look and see not a function or a function. So the first thing you notice is I was looking at only my x values, not my y values. I'm only looking at my x values. If I have an x value that happens more than once, it is not a function. If you look at number 2, you have 2, 3, 4, 5, 6. Those are all different, so it is a function. So it looks like my graphs are messed up down there, but we'll keep going. Okay, so I'm going to put in my x and my y's for each ordered pair. So the first one is going to be 0, -1. The next one is 0, 1. The next one is 2, 2. The next one is 3, 4. And the last one is 4, 0. The thing that makes it not a function is this right here, this repeating 0. That's what makes it not a function. Okay, these two ovals are called a map. We do mapping with our ordered pairs, and this is a little bit different. We're going to have to think about it for a minute because these are our x values and these are our y values. Our domain is our x and our range is our y. Remember when we talked about functions, domain and range, or relations, we talked about when you list the domain, you go from left to right. So I need to take my domain numbers and put them in order from smallest to biggest, and I don't repeat any numbers. So I'm going to end up with these already are in order. So I'm going to write 0, 2, 3, and 4. I only write 0 one time. Even though it repeats, I only need to show it once. My y values are going to be -1, 1, 2, 4, and 0, but I need to put them in order from bottom to top, which is smallest to biggest. So I'm going to put -1, and then 0, 1, 2, and 4. And then I'm going to connect them. I'm going to do like I'm matching, and I'm going to connect the ones that go together. So 0, -1 go together. And 0 also goes with 1. 2 goes with 2. 3 goes with 4. And 4 goes with 0. So that's what a map looks like when you're mapping your ordered pairs. This is the thing right here that shows you that it's not a function. If you have a number that has 2 branches coming off, that means it's not a function. Okay, let's do our one that is a function. So our table, our t-chart's going to look like 2, 5, 3, -2, 4, 3, 5, 1, and 6, 3. And our map is still going to have our x values and our y values. Our x values don't repeat, and they're already in order. So I can put 2, 3, 4, 5, and 6. My y values, I have -2, and I have 2 3s. Remember, I'm only going to write my 3 one time. So I start with -2, 1, 3, and 5. So my 2 goes with my 5. My 3 goes with my -2. My 4 goes with my 3. 5 and 1, and 6 and 3. So look right here. You have this y value with 2 lines coming into it. This is okay. It's still a function. It's over on the other side on number 1 where it's 2 lines coming out of the x value that it's a big no. That is not a function. Okay, let's go down and do the graph and see that it actually turns out the way you thought it would. So let's put those points on. I don't know if I can move that without making a whole big thing. Oh no. You're going to be sorry I did this. Let's see if this takes me more than 5 seconds. I'll start over. Can I move this over here? Okay, that's not horrible. I can handle that. Let me see if I can go back to my writing utensil. It looks like it's still there. Okay, let's see what happens. Let's see if I can draw. Nope, I can't draw. My pen. Oh, it's because it thinks I'm still trying to draw a picture. Looks like it's still... Okay, I can draw now. I don't know what happened. Okay, so let's go ahead and plot our points. I have 0, -1, which is down here. I have 0, 1, 2, 2, 3, 4, and 4, 0. Okay, and if you're looking for not a function, you should think about that vertical line test and go, oh, wait a minute. Those two do not meet the vertical line test. It doesn't matter if I connect them or not. This right here means that it is not a function because those are in a vertical line, which makes it not a function. Let's graph our other one. We have 2, 5. 3, -2. 4, 3. 1, 2, 3, 4, 1, 2, 3. 5, 1. 1, 2, 3, 4, 5, 1. 6, 3. If you thought about doing a vertical line, none of these would be on the same line if you were drawing vertical lines. So it is a function. So it does meet the vertical line test. So 4 different ways you can tell if it's a function. First one, look at the ordered pairs and look at the x values only and see if there's any repeating ones. Look at the t-chart, input, output. If there are repeating values in the input only, it's not a function. You look at your map and you look and see if there's any numbers for x that have 2 branches coming off. If they do, it is not a function. And then finally you graph it and you do a vertical line look, and if there's no points, 2 points that are touching a vertical line, if you draw a vertical line, then it is a function. So write down any questions you have about what I just said, and let's think about this next part. Okay, so we're talking about if it's a function or not, and that's really all we're doing is a yes or no right now. So think about a sphere, and I don't even know how you draw a sphere. There you go. Does that kind of look like a sphere? Okay, the volume of a sphere is the product, which means I'm multiplying this, and cube means to the 3rd power. And you might have seen this formula before. Volume is 4 over 3 pi, and the radius to the 3rd power. So let's think about this. The radius would be from the center to any point outside on the edge of the sphere. Can I have a radius that would have 2 separate volumes? Could I have a radius of 1 that made the volume 4/3 pi, and a radius of 2 which would make the volume 4/3 pi again? No. So this is a function because it is not possible to have, think about, the radius is our x and our volume is our y. Radius is our independent, volume is our dependent. I can't put 2 numbers in the radius that would have different volumes. It's always going to be 1 radius, 1 volume. 1 radius, 1 volume. There's always going to be a 1-to-1 match. So that is what makes it a function. Okay, number 4, okay, we're doing high temperature for the day and the amount of rainfall in inches. The easiest way I can think of to think about this is to make kind of a t-chart. So we would have the temperature and rainfall. So every day, okay, we have the high temperature and how much rain falls. So if the high temperature was 70, there could be however much rainfall there is, right? If the next day the high temperature is 70 again, Could there be a different amount of rainfall? And the answer is yes. It'd be you could have 1 inch one day and 2 inches the next day. So this means it is not a function. Because you can have a high temperature with different amounts of rain, so there is not a one-to-one match for temperature and rainfall. That makes it not a function. Okay. This is where you write down all those questions and big question marks that say, huh? Okay, number 5. Well, all we're doing is function or not a function.